In this video, we're going to look at the atom in the periodic table. The atom is the smallest piece of matter that will retain the properties of that matter. So they are made up of smaller particles, but those particles do not have the properties of those individual atoms. So when I say properties, I'm talking about those physical and chemical properties that we went over in a different video. So if we think of like carbon, for example, those properties that carbon has, that it is crushable, it is flammable, it's a solid, it's black in color. All of those properties would be held constant if we took it down to a single atom of carbon and no further, okay? And again, you can break the atom down into smaller parts, but those parts do not have individual properties distinct to those particular elements. And the atom is broken down into two parts, the nucleus and the electron cloud. The nucleus is the center of the atom. The electron cloud surrounds the nucleus. So the very center of the atom is the nucleus, and then surrounding that like a cloud is the electron cloud, which contains the electrons. Okay. Within the nucleus, you'll find the protons and neutrons. The proton has a positive charge, again located in the nucleus. The neutron has no charge. Okay. The proton sometimes is symbolized with a P with a little plus sign. And the neutron is an N with a 0. Okay. The proton identifies the atom, which means when we talk about the periodic table, the proton is the characteristic that gives the atom its properties. And so the periodic table is ordered by the properties of those particular atoms. And we use that number to identify what the atom is. And these mass numbers, or these masses, you do not need to memorize or anything. They're just on here so you kind of get an idea of the scale or the size of each of these particles. So 1.6 times 10 to the 27th kilograms. That should be negative 27 kilograms. Didn't get that typed in correctly. Is extraordinarily small. So what that means is you have a decimal point and then you have 27 zeros. .26 zeros, and then the 167 kilograms. When you think about this as the size, that particle is extraordinarily small. And a neutron, for all practical purposes, has the same mass as a proton. They vary a little bit, but not by a significant amount. So neutrons and protons weigh approximately the same. Neutrons have no charge, protons have a positive charge. And again, you do not have to memorize these. Then when we come over here to the electron cloud again surrounds the nucleus, and electrons have a negative charge, and they are represented with a E and a little negative symbol. So compare the mass of this electron to the mass of this neutron. This is to the negative 31st, and this is the negative 27th. So you can see that the electron is significantly smaller in mass than the neutron and the proton. Okay, just almost hard to imagine how tiny they are when you're comparing these sizes. Okay. When we go on to some additional vocabulary, we have what is called the atomic number of an atom, and I'll show you when we look at the periodic table where you locate this atomic number. But the atomic number identifies the number of protons in the nucleus. Okay. And since an atom is electrically neutral, which means that they don't have an overall charge, because the matter that's around us is made up of all of the atoms that are out there, and things are not charged. They don't attract one another magnetically. So atoms have an equal amount of positives and negatives within them, which is different from an ion, which we'll talk about in Unit 2. But so an atom is always electrically neutral. That means that their positive and their negative charges are always equal. So you can also use the atomic number to identify the number of electrons in an atom. And then another term is the mass number. Mass number is the number of protons plus the number of neutrons in the nucleus. So you would add protons plus neutrons to get the mass number. You cannot find the number of protons, or excuse me, the number of neutrons on the periodic table. You have to have a way of determining the number of neutrons. So you can't really find this on the periodic table, and you also cannot find the mass number on the periodic table. The mass that's on the periodic table is called atomic mass, which is different than the mass number. They're sometimes very, very similar, but they are different numbers. All right. Within an atom or a group of atoms, the number of neutrons can vary. So if you have a bunch of carbon atoms, they're not all identical. Within the nucleus of those carbon atoms, some of them will have maybe 6 neutrons, some of them may have 7 neutrons. So that those different quantities of neutrons make those particular atoms of carbon behave just a little bit differently and give them different properties. That's why we can have some isotopes of carbon that are radioactive that we can use to date very ancient artifacts by how fast those carbon isotopes have decayed over time. And then we can do some calculating and find out how old that artifact was, because if it was made of living material, then it has some carbon-14 atoms in it, which are radioactive. So that those tiny variances in the number of neutrons change those overall properties of that particular atom. The atoms themselves are the same, meaning that they're all carbon or all hydrogen or all oxygen, but within them there's some slight differences in their properties, and those are things that are called isotopes. Okay, so they will have the same number of protons, which makes them the same element, which makes them have the same atomic number, but they again will have a different number of neutrons, and that gives them those different properties. And we have a couple of ways of identifying or representing those isotopes. And they're isotopic symbols, um, sometimes called atom symbols, just varying. But when you see something like this or something like this in writing or text, that's what it's talking about, is a way of representing a particular isotope. Okay. For this particular one, this top number gives you the mass number, and then the bottom number gives you the atomic number, which again is also found on the periodic table. So if you have this type of symbol, you can find all 3 particles. If you know the atomic number is 6, then that's telling you have 6 protons and 6 electrons. Then you can subtract this mass number and this atomic number and get your number of neutrons. Okay, so you can find the number of all 3 particles with this type of symbol. This type of symbol gives you the elements symbol, obviously. Both of them give you the element symbol that you're talking about. But this one only gives you the mass number. So you would have to use a periodic table, which we're going to look at in a moment, to figure out the number of neutrons, okay? And then sometimes you might see just something like this, which is very similar, again, to this, only it's written in sort of a superscript position, and this will also be the mass number. Okay? So if we want to find, again, the number of neutrons, we're going to subtract the mass number and the atomic number. So this equation, we need to make sure that we know for the test. And then if we equation up here, the mass number is the number of protons plus the number of neutrons, we need to remember this one as well. Okay, so these two would be what definitely need to work our homework and also when we take our test, okay? All right, so now let's take a look at the periodic table. I will provide a periodic table for you for your test, but you're free to print your own, but you will need a periodic table when you're looking at your homework and um, also for your exams, so make sure you just print one out and have it available when you're taking those exams. Just kind of ignore my writing up here. This is for Unit 2. Okay, so the periodic table is arranged by atomic number. So these numbers in the corner are the atomic numbers. Okay, and you can find them in different positions on the periodic table. Sometimes they're in the upper left, might be in the upper right, but they are going to be a whole number. There's not any decimal points with any of these. And they're always, will go 1, 2, 3, 4, 5, 6, 7, etc. Okay? And so again, this atomic number is going to tell you the number of um, protons and electrons in an atom. And this periodic table is again ordered by the number, the type of properties that they have, because the protons give the identifying properties to the particular atoms. Okay, this number right here is the atomic mass, and again, like I said before, this is different than the mass number. This is an average mass or average weight of all of the known isotopes of that particular atom. So it's a weighted average for that particular atom. That's why there's a decimal point there, because when you weight that out as an average, then you're going to get some degree of decimal points. Mass numbers will never have decimal points because you can't have pieces of neutrons, you can't have pieces of protons. You have whole neutrons and whole protons in the nucleus. So that's why the mass number is not on this particular periodic table. Okay. We also call these the up and down, the vertical rows of a periodic table. The groups or families. Okay. So this hydrogen down to francium, okay, that's considered a group. Beryllium down to radium, that is another group. And if you notice, these numbers along the top are called the group number. Okay, so this is the group number. All right, and then going horizontally, these are called periods. Okay, so from potassium to krypton, that is a period. And this periodic table, it does not have a numbered, but they are numbered 1, 2, 3, 4, 5, 6, 7. Okay. If you notice down here at the bottom, there is a pull-out section. You can see where that they tuck right up in here. These are called rare earth elements, and they're just pulled out as a separate section, but they are part of the periodic table. Okay. This part of the periodic table, groups 3 through 12, are called transition elements or transition metals. Okay. This entire section, this stair-step line that I've drawn in here, is printed out on a lot of periodic tables, but this is the transitioning zone, okay? Everything to the left of this line is considered a metal. Except hydrogen, okay? So hydrogen is not a metal, all right? Anything over here on the right side of the stair-steppy line is the nonmetals. Okay, and then bordering this stair-steppy line, These are called semi-metals or metalloids. Okay, I'm going to put a dot for those: boron, silicon, germanium, arsenic. Okay, these are semi-metals or metalloids. Okay, so you can have a group number. Okay, you can have a period number. You can have a category of metals, non-metals, metalloids. These semi-metals or metalloids they're like the transitioning, they're the bridge from the metals over to the non-metals, and they have properties of both. Okay, so they're kind of the in-between elements. They have some properties of metals, are good conductors of heat and electricity, and then they also have some properties of non-metals. Many of them are brittle. That means that they break, whereas a metal, you can mold it and form it into a different object. Okay, so be ready. Um, the types of questions that you would see over this is identify the name of an element. So if you were given CO and asked what element is this, you would come to your periodic table and you would look and see that CO is right here and it is cobalt. Okay, or what is the symbol for zinc? So you would find zinc and you would see that it has a symbol of Zn. Okay, so we're going to go over and look at your this week's homework really quickly, so you can get an idea of that, and then also lecture resource C. All right, so this is asking you about your periodic table. How are the elements grouped? Okay, well, they're grouped according to their chemical and physical properties, because remember, the proton is what gives it its chemical or physical property. Okay, then this is asking about the arrangement of the periodic table. The vertical arrangement, which means the up and down, those are called groups. Okay, the horizontal, side to side, those are the periods. Okay, element 19 begins this arrangement of the periodic table. So we need to come and look at our periodic table. Element 19 is right here, potassium. The screen's kind of cut off, but this is 19. So this would be a period. It begins a period. And then element 9 begins this arrangement. Okay, so here's element 9, so it's the beginning of a group. Okay, let's go down here. This one, it wants to know the number of protons in the nucleus of these 4 different atoms. Identify which element is indicated by the number of protons. We want the symbol and not the name. So 19 protons, that means the atomic number is 19. We come out here and we see that that's K. We just type in our capital K. 20 protons, right next to it is Ca, calcium. All right, and so on and so forth. And this one, it wants to do the same thing. It wants you to tell which element you're seeing. We don't need the mass number for this. We just need the atomic number. So go to your periodic table, find this atomic number, and type in the symbol for that. Okay. Here, we want to know the isotopes. We know isotopes have the same atomic number. So when we look at these symbols, the atomic number is on the bottom. So you're looking for the ones that have the same number down here on the bottom. So that would be B and C. Over here, there's 3 isotopes because there's 3 tens on the bottom. So all 3 of those would be isotopes. I'm going to try to find one that on this one, you're using your period and your group number. Now, some periodic tables have an older system of numbering the groups, so that's why this is in parentheses. But here we're going to go to a period 6, group 13. So here's period 6. Here's group 13. So you just read it sort of like map coordinates. 6 and 13 is thallium, TL. And then we would put that in. Make sure your second letter is always lowercase. Period 5, group 11. So here's period 5, Group 11 is right here, so that's silver. Put in AG. And remember that the ones that don't really match their names we've known about them for a long time, so their symbol is based off their Latin name. Okay. All right. Find. All right, so here we're categorizing just metal, semi-metal, or non-metal, so it's drag and drop. Use your periodic table and identify which one belongs where. The table also has some unique names for particular groups, and these are called their family names. A lot of periodic tables online will already have those printed out for you, but these are the family names that you need to know based on the fact that they have very similar properties. This first one is called the alkali metals. That's group 1. Okay. Now hydrogen is not included. Okay. Hydrogen is not an alkali metal. Hydrogen is a nonmetal. Okay. Okay. Group 2, these are called alkaline earth. Right? We already talked about these being called transition metals. Okay. And then skipping all the way over here to fluorine. Those are that group, this entire group. These are called halogens. Okay. And then the last group, group 18, these are non-metals. Excuse me, noble gases. They are non-metals, but this family's the noble gases, or sometimes called inert gases. Okay. And then if you look at this section right here, this big chunk from boron all the way down, and then these 2 rows over here. So basically the tall sections of the periodic table, that's sometimes called the representative or main group elements. And that's just vocabulary that you might come across in your reading or in different parts of the periodic table. All right, so now let's look at your lecture resource C. Okay, here we are circling the symbol of the transition element and underlining the symbol for the hydrogen. Find these lecture resources in your introduction module. And again, these are very good study guides for what you might see on your exam. You'll need your periodic table and this document to be able to work through these. We want to go to the transition element, so we're just searching through this middle section for transition element. So we know copper is a transition element. We are going to circle copper. Copper's right here. Okay, right here. Then this one, tungsten's right here. I obviously know these better than you guys do. Zirconium, ZR, right here. Okay. Silver, right here. So these are the 3 transition elements, and we want to underline the halogens. This family right here is the halogens. chlorine down. So we see Cl is a halogen, so we want to underline Cl. And then iodine is also there as a halogen. Okay. Now, these are the older naming, numbering of the groups. So this would be group 1, group 2, group 17, and group 18 with the current numbering. So we know that these are the alkalis, the alkali metals. We know these are the alkaline earth. We know these are the halogens. And we know these are the noble gases. Okay. And here we're just doing some grid coordinate. Noble gas in period 2. So on our periodic table, these are the noble gases. Helium is period 1. Neon is period 2. We have Ne. Halogen in period 2. Period 2. Always count from the outside because sometimes you skip over a hydrogen and helium, and then that puts your numbers off for the periods, okay? So I want halogen in period 2. So here's period 2. Here's our halogen. So that's F, okay? Here we're just identifying them as metal, nonmetal, or metalloid. So carbon is here. This is our nonmetal section. It's a nonmetal. Magnesium is here. So that's our metal section. Chlorine is here. That's a nonmetal. Okay. Then this particular section, we are wanting to identify like proton, electron, and neutron. Okay. So nitrogen's right here. Symbol is N. Its atomic number is right here, which is 7. And that means it will have 7 protons and 7 electrons. To find the neutrons, remember we're taking the mass minus the protons, or mass minus the atomic number to get the neutrons. So 14 minus 7 is 7. Okay. Magnesium is right here, number 12. It's Mg. Atomic number of 12. Protons 12. Electrons 12. Then to get the mass number, we want to add protons plus neutrons. 12 and 12, 24. Okay. Mass number is always going to be larger than any of your subatomic particles because you're adding 2 subatomic particles together to get the mass number. Okay. Let's go down here to this one. Protons is 19. That means our atomic number is 19. So we come over here and we see that 19 is K for potassium. And that is a K. And then our mass number, we're going to add neutrons plus protons, so that's 39. And then our electron number is 19. All right? So just practice this and work on your homework. And this, again, is a good study guide. And this is the last lecture material for this particular unit.